Okay, class, today we're going to be building those linear models from data. So yesterday we talked about just y equals mx plus b, getting a linear function. Today we're going to get some data points to do that. So the first thing we're going to do with this data is create a scatter diagram. Now, just make sure that you kind of want to look at what the values are for x and y before you create this diagram. For example, it looks like my x's go between about 39 to about 66, so almost 40 to like 70 or something like that. So it says treating weight as the independent variable, which is your x. So I'm going to just come down here and make an axis. Now when you make a scatter diagram, you do want to label everything. So this is weight. And this is calories. It's in grams. Okay. I'm just going to put that so I know the weight. Now I'm going to do my values. So I'm going to kind of do like a little thing here to say, okay, we're starting at, we're skipping a few values, and then I'm going to say this is 0, but then we're starting at 30, 40, 50, 60, 70. Okay, I probably could have spaced those a little better, but it's not that bad. And then for the height, I want to do another break and then say I'm going to start at 200 because it looks like that's the lowest calories, or well, 210 is. 210. And then so far and so forth, 20, 30, 40, 50, 60, 70, 280. I'll stop at 280 up here. So now you just plot your dots. So you got 44.2 and 230. So 230 is right here. 44.2 is about halfway. So you just plot all the dots that you have in here. 44.8, which is about the same thing, and 230. So that's right next to that one. There's two right next to each other. 61.3. It gives you 270 calories. So that'd be about there. 66 gives you about 280. 47, so that's 30, 45, 47. Actually, I'm a little off on these, but 47 gives you 220, which is actually down here. So that dot's a little off from what the other ones are. So that's 40, 50. Or 50, 60, 70. So we have 58 is right before 60, and we're all the way up at 280 for that one. 61 is up at 280. And then we are at 39 or 40, and we're at 210. Okay, so if you look at this data, you can see that there's a positive correlation. It's not perfect, but there is a positive correlation. And that is the type of relationship that exists here. So we'll say it's a positive correlation. Which means that as weight goes up, so do the calories. Which makes sense. More food, the heavier the food, the more calories it is. Especially when we're dealing with candy. So now what we're going to do is take two of the points and make a line of best fit between these points. So in order to do that, this is where we need a slope and then one of our points. Now, I didn't write this down, and I will over here. So we need point slope form method, point slope form equation. And I think I gave you guys this back in the first packet. Point slope form is y minus y1 equals the slope times x minus x1. Because we don't know the intercept. That's why we have to use this form. Alright, so to do this, we need to get a slope first. So my slope is equal to y2 minus y1. So 210 minus 280 over x2, 39.52, minus 61.12. And when you do that and type that in, you actually get a nice fraction, believe it or not. You get 175 over 54 if you type that all in and hit math frac. So that's our slope. Now we need to find or use a point. I chose this point here because it's smaller numbers. So now I'm going to put this into the formula I gave you up above. Y minus the y coordinate, y1, is equal to the slope times x minus the x coordinate. All right, and then what we want to do is solve for y. When you solve for y, you distribute this, and then also add 210 to this number right here, whatever that you get after you distribute. And when you do that, you get 175 over 54 times x plus 81.926. Then it says graph the line on the scatter diagram drawn in part A. Well, what you can do is just connect those two dots. So 39, 52, 210, and 61, 12, 280. So 61, 12, 280, which was, what were my 280 ones? 280 was 66, 58, and 61. So I'm assuming it's this one. And then, what was the other one? 39 was my 210. It was this one. So what you can do is just connect those dots. And there's our scatter diagram. All right. Use the linear model to predict the number of calories if the candy bar weighs 62. It should say 0.3 grams. This should be a dot. So we can just put that in as our x. Your y is the weight. I'm going to input a 62.3. Now, if I look at this, before I type that all in, and you can pause at any time, I'm going to look back at my data. 62 would probably be on the higher end. It might be higher than 280 calories. So you should kind of get an idea of where this is happening. And sure enough, when you type this in, this is approximately 283.82 calories. And then finally it says, interpret the slope that we found in part C. So the slope was 175 over 54, but if we talk about that in terms of a decimal, that's 3.24. And remember, and I'm going to rewrite it like this, 3.24 over 1. This is your y, which is your weight. No, I'm sorry, your y is your calories. And this is your weight. And what this is saying is, for every increase, every 1 gram increase in weight, the calories will increase by 3.24. So every time you want to add a gram of weight to your candy bar, you're adding about 3.24 calories to your candy bar. That is what the slope is saying. So to interpret a slope again, I would write it as a fraction, but I would get it as a number first and then just put it over 1. Figure out what units you're dealing with, and then talk about how if the weight goes up by 1, what does the top number do? It goes up by 3.24. Okay? So that's interpreting the slope. And that is it for today.